Hello, good people, and welcome back to another math video. We're continuing with the 5-day review. This is the video for Wednesday's problems, March 25th, 2020. So number one asks us to simplify and show all of our work. And I hope when you saw this you remembered PEMDAS. Please excuse my dear Aunt Sally, or purple elephants may destroy a school. But this is the order of operations. So the P stands for parentheses. We don't have any, so that's great. The E stands for exponents. Do we have exponents? Yes, we do. You need to take care of that first. So 3 squared, that's the same as 3 times 3. So we will take care of that first, and that is going to be 9. So I'm going to turn that into 9. I'm going to do a simple cross out so I don't accidentally use it again, and I'm going to write everything else I didn't use. Next, do I have any more exponents? No. So I'm on to multiplication, which I do have. I have 9 times 5, which is 45. So I'm going to do a simple cross out, write down 45, and I'm going to write down everything else I didn't use. Do I have any more multiplication or division? Nope, I just have addition. 45 plus 4 is 49, and that's my final answer. Number 2, model and solve 4 divided by 2/3. And they gave you just a line there that looked kind of like this. If this was me, I would kind of split this up like this so that I would have 4 things, because this is 4 divided into 2/3 chunks. And then I would make my lines a little bit heavier here, because I'm actually going to make some more lines. So we're splitting each of these into 2/3 chunks. So I'm splitting these into thirds. And they're asking me to divide 4 into 2/3 chunks. So I would have, there's a 2/3 chunk right there. And that was kind of for that first one. Here's a 2/3 chunk here. Here's a 2/3 chunk here. And here's a 2/3 chunk there. So I made 4 of them right there, but I also have a number of these thirds that are left over, these right here. So I can use those. I don't just need to leave them hanging out there. I can use them. So I could kind of use this one right here. Sorry, that's not helpful. I can use this one and this one, and that would like be another 2/3. Those two would connect to be another 2/3, and then I have another one here and here, and I can connect those together, and those would each be a 2/3 chunk too. So I have 1 2/3 chunk, 2, 3, 4, 5, and 6. So the answer is actually 6. I made 6 chunks right there. That was my model. So some of you like to see things in a picture, so there's kind of a picture format. Others of you just want to use the numbers, so I can do it that way too. 4 divided by 2/3. Well, when we divide fractions, we keep, change, flip. So I'm going to keep this, change this, and flip this. And now I have a multiplication problem. 4 times 3 is 12 over 2, and that would reduce to 6. So whether we modeled it with a picture, we got 6 chunks, or whether we just used the numbers, we also got 6 chunks. Number 3 asks you to, it says, based on the diagram, describe how a parallelogram and a rectangle are related. And they have a parallelogram. Now, a parallelogram, what that is it's hard to draw a perfect one, but what that means is we're saying that this edge and this edge, these are parallel. That means they never get closer together, they never get farther apart. But also this edge and this edge are parallel to each other. So a parallelogram has 2 sets of parallel sides. Now they're asking, how are a parallelogram and a rectangle similar? And they drew this little picture here. They kind of dotted off this part of the triangle, this part of the parallelogram, making it a triangle, and they drew this arrow over here. And what they're trying to show you is you could remove that portion of the parallelogram and move it over here, and then you would have a rectangle. So a parallelogram and a rectangle are pretty similar in that way. And what they're hoping for you to see is that a parallelogram and a rectangle would have the same area if they had the same base, there's the base, and the same height. So if this, let's just say this is 10 and this is 4. And then I'm going to do my best to draw a rectangle, and I'll say that this one is 10 and this is 4. The area of these two shapes, that means how much they cover, would be equal. Number 4, just some straight up multiplying of fractions. When we multiply fractions, it's about as easy as it gets with fractions anyway. We just multiply straight across. 5 times 1 is 5. 8 times 2 is 16. 5/16. Could this reduce? Well, there is not a number other than 1 that can go into both 5 and 16, so that is my final answer. 1 times 4 is 4. 4 times 5 is 20. And while that is the correct answer, this answer is not in lowest terms because both the numerator and the denominator could be divided by 4, and my final answer would be 1/5. Number 5 is asking us to use the greater than or less than symbols to make each of these statements true, and use a number line for help if you need to. So the first one is comparing 2 and 7, and we would use this symbol and read it as 2 is less than 7. The next one, -5 and 4. -5 is less than +4. 3 and 0. Well, 3 is greater than 0. 0 and -3. This actually might come across as a little tricky because we think of 0 as having nothing, but it actually is more than -3 because it's more. One way to think about it, these might be like temperatures. If I had a temperature of 0, that would actually be warmer than a temperature of -3. Another way to think about it would be money. If you had $0, that would be better than having -3. -3 would be like you owed someone $3. And the last one, -1 and 1. -1 is less than 1. Okay, I believe that is it, folks. So thanks for watching. Hope you have a great day, and we'll see you again soon for another video.